Yay! How's it going? A few months ago, well, 6 months ago? How's this? A while ago, I was traveling. Laptop in a bag, USB drive in my pocket, and it hit me. If I lose this, what actually protects the files? They're password protected, but what does that really mean? That question sent me down a rabbit hole, and today I want to talk about why encryption isn't the hard part. Trust is. We hear this phrase all the time. Your data is encrypted. Cloud storage companies say it. Operating systems say it. Compression tools say it. But here's the real question. No one asks, right? Who controls the keys? Because encryption without key control is basically a promise. Take cloud storage. Yes, strong encryption. Yes, modern algorithms. But if the company manages the keys, that means there has to be a recovery mechanism. And recovery mechanisms are designed for support, not secrecy. Same with things like BitLocker. BitLocker uses solid crypto. No argument there. But recovery keys can be backed up. Enterprise environments is enterprise environments escrow them by design, right? That's not evil. That's architecture, right? That's by design. But it means the encryption ultimately depends on policy, not just math. If there's a recovery path you don't control, you don't fully control the encryption. This is the one that really got me. I right clicked the file, I compressed it, I added a password, and then I stopped and thought, what is that password actually doing? Is it being stretched properly? Is it using modern ciphers? Is it vulnerable to offline guessing? Most people, like myself included, just assume password means safe, right? But unless you know how it's implemented, you're trusting a black box. So this is where I landed. Security isn't about whether Microsoft or Google are bad actors. It's about whether you control the keys. If you can't explain how your encryption works, then you're not securing data. You're outsourcing trust. Math doesn't care about brand names. So I decided to do something a little different. I wrote my own file encryption tool. Not my own algorithm. That would be reckless, right? I used AES, a well understood, heavily audited standard. But I controlled the design. I control how the key is derived, how the file is authenticated, where the keys live. And what happens when something goes wrong? No cloud, no telemetry, no recovery keys. Just math and code I can read. AES, industry standard encryption, right? PBKDF2 slows down password guessing, right? Burn and churn that CPU. HMACs, right? We're going to detect that tampering. All right, so let's take a look at it. I have a thumb drive plugged in. All right, let's create a file. Hello world. We're going to pipe that. All right, do we have more? We do. Cool. All right, so we have a file. Rock on. All right. Keymaster, right? And that drive, I believe, is on H. And let's put it back to H. And we're going to encrypt. Cool. Simple password, right? I'm going to do the wrong password. Boom. All right, cool. So let's do that again. And we're going to do the correct password. Cool. And let's do basic decrypt. And the file that we are decrypting. Before, let me do this. Right, as you can see, we created the encrypted file. Let's do more. And let's see what this outputs, right? Gobbledygook, right? So if we were to take it into a hex editor, we would probably see random hex not looking like the text file that we created, right? That was supposed to be more. So we've encrypted it, right? So let's decrypt that. So we're going to suck in that test.nux file, and we want to output that to a what? Let's do test2.nux. Let's do text. Make it real world, right? All right. So we're going to decrypt. We got our source. We got our destination. Let's try it. Enter password, right? Let's do the wrong password. Boom, right? Let's do the right password this time, if I remember it. Perfect. All right. So let's head back to the other tab. And if we were to list that, here we see test2, right? Test2.txt. So let's take a look at that file. Bada bing, bada boom, right? So awesome. And I will upload this to the GitHub so y'all can take a look at it. But it's fairly documented, right? About everything is documented as to why we're doing what we're doing. A dose of reality. This doesn't protect you from malware. It doesn't protect you from keyloggers or compromised systems. Encryption protects data at rest. But what it does give you is ownership. This isn't about paranoia. It's about the ability to make meaningful choices and control outcomes. Convenience is great until it's not. If you're going to trust someone with your data, make sure you understand what you're trusting them with. And sometimes the most secure option is the one you understand. This is NuXOlogy. I'll see you next time.